Hey everyone, and welcome back. Tonight, we're going deep, really deep. We're diving into star factories.
Ooh, star factories.
Yeah, we've got some really interesting research and articles all about these stellar nurseries where stars are born.
Cool.
And get this, the elements that make up our bodies. So it's the stuff we're literally made of.
Yeah.
It was forged in the heart of stars.
Really?
Yeah. We are stardust, every one of us. But here's the thing. Star formation is on the decline.
Oh.
And that has some pretty big implications for the future of the universe, and maybe even for us. So that's what we're diving into tonight.
I think it's interesting that when we talk about star factories, we're not just talking about, these distant little twinkling points of light.
Right.
We're talking about the very building blocks of, well, everything. It really shifts your perspective when you think about it that way.
It really does. So,
Yeah.
okay, let's paint a picture here. What exactly is a star factory?
So imagine a massive cloud of gas and dust stretching for light years across space. It's cold, it's dark, and it seems, pretty lifeless at first. But within this cloud, gravity's at work, slowly pulling everything inward. This causes the cloud to collapse in on itself, spinning faster and faster as it shrinks, and the center. It gets incredibly hot, dense from all this pressure.
So it's like a giant cosmic snowball just gathering more and more snow as it rolls downhill.
Exactly, and it's getting bigger and faster as it goes.
Yeah.
Eventually, the temperature and pressure at the core of this spinning cloud reach a critical point, and that's when things get really interesting. Nuclear fusion ignites, and boom, a star is born, a brilliant, shining ball of light and energy just erupting from the darkness.
Wow. It's hard to even wrap your head around the sheer scale and power of that. But if I'm getting this right, it's not just stars that are born in these clouds, right?
Yeah.
Our source mentioned that planetary systems also form in these stellar nurseries.
Right. Think about our own solar system. I mean, our sun, along with all the planets orbiting around it, they formed from the same giant cloud of gas and dust billions of years ago.
So our sun, which gives us light and warmth, and the Earth itself, were all born from the same cosmic event.
Exactly.
That's mind-blowing.
Yeah.
But now for the not-so-good news. What's this I hear about star formation slowing down?
Unfortunately, that's true. Studies show that star formation rates have plummeted by a staggering 95% since their peak billions of years ago. Galaxies are running out of the raw materials, those massive clouds of gas and dust needed to make new stars.
So are we literally running out of stars?
Well,
What happens then? That sounds a little ominous.
Well, it does have some pretty significant implications. Stars are the ultimate cosmic recyclers. When they die, often in these spectacular supernova explosions, they scatter heavier elements, carbon, oxygen, iron, back out into space. And these elements are the building blocks for new stars, new planets, even life as we know it.
Okay, so it's like a giant cosmic ecosystem. Stars being born, living out their lives, and then dying to provide the ingredients for the next generation. It's a beautiful cycle. But if new stars aren't forming, that cycle breaks down.
Exactly. And without that renewal, the universe would eventually become a much darker, colder, and less vibrant place.
That's a pretty sobering thought.
Yeah.
It makes you realize how interconnected everything is. We tend to think of space as this vast emptiness, but it's really a delicate balance of creation and destruction, isn't it?
It is, and that's why understanding star formation and its decline is so important. It's not just about stars, it's about understanding the fundamental processes that drive the evolution of the universe and the potential for life itself.
Okay, so star formation is declining.
Yeah.
That's not great. But what if it stopped completely? I know it's a hypothetical, but paint me a picture. What would the universe look like without those stellar nurseries churning out new stars?
Let's fast forward billions of years. Our sun, like all stars, has a finite lifespan. It will eventually run out of fuel, swell into a red giant, engulfing the inner planets, including Earth.
Whoa, hold on.
But that's just our solar system.
Okay.
On a cosmic scale, without new stars being born, the universe would gradually become dimmer as existing stars slowly fade away. Eventually, the only sources of light would be the remnants of dead stars, like white dwarfs, neutron stars, and those mysterious cosmic vacuum cleaners, black holes, slowly gobbling up whatever matter remains.
Wow, that's a lot to take in.
Yeah.
It's like the ultimate cosmic fade to black. So no more brilliant nebulae, no more twinkling constellations, just an ever-expanding sea of darkness. I don't know about you, but that doesn't sound like a very exciting future.
It's certainly a thought-provoking scenario, and it really underscores the importance of those star factories we've been talking about. They're not just creating stars, they're creating the possibility for light, warmth, planets, and perhaps even life itself.
It makes you wonder if there's anything we can do to help to keep those cosmic fires burning. I mean, besides becoming astrophysicists and figuring out how to jumpstart star formation, which sounds a bit beyond my skill set at the moment.
That's a great question, and you might be surprised to hear that there is something we can all do right here on Earth to contribute to our understanding of star formation and the universe as a whole.
Intrigued. What could we possibly do from down here to impact something so vast and distant?
It might seem like a small thing, but it can actually make a big difference reducing light pollution.
Great pollution.
Yeah. Our sources highlight the impact of excessive artificial light from our cities, towns, and even our homes. It creates this luminous fog that obscures our view of the night sky, making it much harder for astronomers to observe and study those distant star-forming regions.
So by simply dimming our lights, we're actually helping scientists get a clearer picture of what's happening out there in the universe. I never thought of it that way.
That's right. And the more we understand about star formation, the better equipped we'll be to address the challenges posed by its decline. Who knows? Maybe one day we'll even figure out how to restart those cosmic engines and ensure a brighter future for the universe.
That would be pretty amazing. But even if we don't crack the code of cosmic renewal, just appreciating the night sky and doing our part to protect it feels like a worthwhile endeavor. It's a reminder that we're part of something much bigger than ourselves.
Absolutely. And speaking of the interconnectedness of the universe, there's one more fascinating detail from our research that I think you'll find particularly interesting. It has to do with how some galaxies, including our own Milky Way, acquire the gas they need for star formation.
Okay, I'm all ears. Fill me in on this cosmic secret.
Well, let's just say that the Milky Way isn't exactly shy about getting what it wants. It's been caught red-handed, so to speak, engaging in a bit of cosmic cannibalism.
Wait, what?
Yeah.
Cannibalism? You mean the Milky Way is eating other galaxies?
Pretty much.
That doesn't sound very neighborly.
It's not exactly a friendly potluck, that's for sure. But it is a fascinating example of how galaxies interact and evolve over billions of years. Our sources call it the Galactic Hunger Games, and it's a competition for resources on a truly epic scale.
Okay, I am definitely hooked now. This is getting good. Tell me more about these Galactic Hunger Games and how our Milky Way plays the game.
Well, think of it this way.
So we left off with this image of the Milky Way as a cosmic cannibal, which is pretty wild thought. It's not exactly the peaceful spiral galaxy I learned about in school.
It's definitely a more dynamic picture than we often imagine. You know, over billions of years, the Milky Way has actually pulled in gas from numerous smaller galaxies, adding to its own mass and fueling its star-forming activities. It's like a cosmic power move.
Oh, wow.
Gathering resources to keep those stellar nurseries going.
So it's not just about individual stars being born and dying. It's about these larger interactions between galaxies, this cosmic dance of creation and destruction playing out on a grand scale.
Exactly. And it makes you wonder, you know, if the Milky Way is this hungry for gas to fuel its star factories, what happens when it runs out of smaller galaxies to snack on?
Yeah, that's a good question. Does it just, fade away? Or does it find other ways to get what it needs?
Well, it turns out the Milky Way has a few tricks up its sleeve. One possibility is that it could merge with another large galaxy, like our neighbor Andromeda. Astronomers predict that this kind of galactic collision is actually in our future. Billions of years from now, of course.
Whoa, a galactic merger. That sounds intense. What would happen during something like that?
It would be a spectacular event, lasting for millions of years. The two galaxies would distort each other's shapes as they approach, their spiral arms twisting and stretching under the influence of gravity. And eventually, they would collide and merge, their gas clouds mixing and triggering a burst of new star formation.
So even though individual stars are dying, these larger galactic events can create new opportunities for star birth. It's like a phoenix rising from the ashes, a new chapter in the cosmic story.
That's a great way to put it. It's a reminder that the universe is constantly changing, evolving, and finding new ways to create. And even though star formation is declining overall, there are still these pockets of intense star birth happening in these merging galaxies.
It's amazing to think about these processes unfolding over such vast stretches of time. It makes our human lifespan feel incredibly short in comparison.
It does put things in perspective, doesn't it? But it also highlights the incredible opportunity we have to witness and study these cosmic events. You know, even though our time is limited, we can still contribute to our understanding of the universe.
And you mentioned earlier that one way we could do that is by reducing light pollution. I'm curious to learn more about that. How does dimming our lights here on Earth actually help scientists study these distant galaxies and star-forming regions?
It's all about clarity. Light pollution from our cities and towns creates a haze that washes out the fainter stars, and it makes it much more difficult for astronomers to observe those distant objects. By reducing light pollution, we're essentially giving them a clearer view of the cosmos.
So it's like trying to look at a beautiful painting through a dirty window.
Yeah.
By cleaning the window, we can see the details more clearly and appreciate the artwork more fully.
That's a great analogy. And it's not just about professional astronomers. Light pollution also impacts our own ability to enjoy the night sky. Imagine being able to step outside and see the Milky Way stretching across the sky, this dazzling river of stars. That's something that's becoming increasingly rare in our modern world.
Yeah, I've only seen the Milky Way a handful of times, and it really is a breathtaking sight. It makes you feel small, but also connected to something much bigger than yourself. It's definitely something worth protecting.
Absolutely. And there are a number of simple things we can do to reduce light pollution. Switching to dimmer light bulbs, using motion-activated lights, shielding outdoor lights so they point downward, all small changes that can make a big difference.
So by making these changes in our daily lives, we're not just helping scientists study the universe, we're also reclaiming our own connection to the night sky. It's a win-win. But speaking of the night sky, I want to go back to something we talked about earlier, the idea that we are stardust. It's a beautiful concept, but it also raises some interesting questions.
I agree. What are your thoughts?
Well, if the elements that make up our bodies were literally forged in stars, does that mean we're destined to return to them one day? Is there a kind of cosmic cycle of life and death happening, not just on a galactic scale, but within ourselves as well?
That's a profound question, and it touches on some deep philosophical ideas about our place in the universe. From a scientific perspective, we know that when we die, our bodies decompose and the elements that make us up return to the Earth. Those elements might eventually be incorporated into new life forms, or they might be subducted back into the Earth's mantle, and eventually recycled through geological processes.
So even though we don't literally return to the stars, the matter that makes us up continues to be part of this larger cycle of creation and destruction. It's a comforting thought in a way.
It is, and it highlights the interconnectedness of everything in the universe, from the smallest atom to the largest galaxy.
Okay, so we've talked about the awe-inspiring beauty of star factories, the cosmic recycling of elements, and the potential consequences of declining star formation. But our research also mentioned this fascinating concept of the galactic Hunger Games. Can you tell me more about that?
Of course, we were starting to delve into that before. As we mentioned, some galaxies, including our own Milky Way, acquire the gas they need for star formation by, let's say, borrowing it from smaller nearby galaxies.
Right. It's a bit like galactic competition for resources, with the Milky Way being a bit of a bully on the cosmic playground. But how does this galactic cannibalism actually work? What does it look like?
Well, imagine a small, unsuspecting galaxy wandering too close to the Milky Way. The Milky Way's powerful gravity starts to pull on that smaller galaxy, distorting its shape and drawing out these long streams of gas and stars.
So it's like a cosmic tug of war, with the Milky Way slowly reeling in its prey.
Exactly. And over millions of years, that smaller galaxy can be completely absorbed into the Milky Way, its gas and stars becoming part of our galaxy's own structure. It's a dramatic example of how galaxies evolve and grow over time.
It's incredible to think about the sheer scale and power of these galactic interactions. But I have to ask, if the Milky Way is so good at gobbling up its neighbors, what does that mean for its future? Will it eventually run out of galaxies to consume?
It's a question astronomers are still exploring. But there's evidence that the Milky Way might be gearing up for its biggest merger yet, a collision with our neighboring galaxy, Andromeda.
Wait, a collision with Andromeda? That sounds like something straight out of a science fiction movie. Tell me more.
Well, Andromeda is a spiral galaxy similar in size to the Milky Way, and it's currently hurtling towards us at a speed of about 250,000 miles per hour.
Wow, that's fast. When is this cosmic collision supposed to happen?
Don't worry, it's not happening anytime soon. Astronomers predict that the two galaxies will collide in about 4.5 billion years.
Okay, that gives us a little bit of time to prepare. But seriously, what will happen when these two galactic giants collide?
It will be a spectacular event lasting for millions of years. The two galaxies will distort each other's shapes as they approach, their spiral arms twisting and stretching under the influence of gravity. Eventually, they will merge, their gas clouds mixing and triggering a burst of new star formation.
So it's not just about destruction, it's also about creation. A new galaxy will be born from the ashes of the old ones.
Right.
That's a pretty mind-blowing thought.
It is. And it highlights the cyclical nature of the universe, with death and rebirth playing out on a grand scale. But there's another intriguing aspect to these galactic mergers that I think you'll find interesting.
I'm all ears. What else is happening during this cosmic dance?
Well, remember those supermassive black holes that we talked about earlier, the ones that lurk at the center of most galaxies?
Yeah, the cosmic vacuum cleaners that gobble up anything that gets too close.
Exactly. Well, during a galactic merger, the supermassive black holes at the centers of the two colliding galaxies will also eventually spiral towards each other and merge, creating an even more massive black hole.
Whoa! A black hole merger. That sounds like something that could rip a hole in the fabric of space-time.
It's certainly an event that would release an incredible amount of energy, but it's also a process that scientists are eager to study because it could help us unlock some of the mysteries of gravity and the evolution of the universe.
It's amazing to think that we can actually observe these events happening billions of light years away. It makes you realize just how far we've come in our understanding of the cosmos.
It does, and it makes you wonder what other incredible discoveries await us as we continue to explore the universe.
I'm excited to find out. But before we get too lost in the vastness of space, I want to bring it back down to Earth for a moment. We've talked a lot about the big picture, but I'm curious to hear your thoughts on what this all means for us here on this little blue planet.
That's a great question, and it's one that I think we all grapple with when we contemplate the vastness of the universe. You know, it's easy to feel small and insignificant when faced with these cosmic scales of time and space. But I think it's important to remember that we are a part of this universe, connected to it in ways that we are only beginning to understand.
I like that. We're not just passive observers, we're active participants in this grand cosmic drama.
Exactly. And even though our individual lives are fleeting in comparison to the lifespan of a star or a galaxy, we still have the power to make a difference, to contribute to our understanding of the universe, and to inspire future generations to keep exploring.
That's a hopeful thought. And it brings us back to that question we posed earlier. What can we do here on Earth to make a difference in the face of these cosmic challenges?
Well, we've talked about reducing light pollution, which is a tangible action we can all take to support scientific research and preserve our view of the night sky. But I think there's something even more fundamental that we can do.
What's that?
Cultivate curiosity, keep asking questions, never lose your sense of wonder. The universe is full of mysteries waiting to be uncovered. And it's our innate curiosity that drives us to explore, to learn, and to expand our understanding of our place in the cosmos.
I love that. It's not just about the answers, it's about the journey, the quest for knowledge, the constant striving to understand more about the universe and our place within it.
Exactly. And who knows, maybe by fostering that sense of wonder in ourselves and in future generations, we'll unlock the secrets of the universe and ensure a brighter future for humanity among the stars.
That's a beautiful thought to end on. But before we wrap up this deep dive, I want to touch on one more fascinating detail from our research. It has to do with the fate of our sun and the Earth billions of years from now. I know it's a bit of a morbid topic, but I think it's important to consider the full scope of the cosmic story, even the parts that are a little bit scary.
I agree. It's all part of the grand narrative of the universe. What specifically caught your attention?
Well, our sources mentioned that as the sun nears the end of its life, it will swell into a red giant engulfing the inner planets, including Earth. But then, after that dramatic expansion, it will eventually shrink down to a white dwarf, a tiny, dense remnant of its former self. What happens to the outer planets, like Jupiter and Saturn, during all of this? Do they just drift off into space? Or do they experience some kind of transformation as well?
That's a great question, and it's one that astronomers are still actively researching. But there are some fascinating theories about what might happen to the outer planets as the sun evolves.
Okay, tell me more. I'm eager to hear these theories.
Well, one possibility is that as the sun expands into a red giant, its outer layers will engulf the inner planets, but might not reach the outer planets. Those outer planets, including Jupiter and Saturn, could survive the red giant phase and continue to orbit the white dwarf remnant of the sun.
So they might end up orbiting a much smaller, dimmer star. That's a strange image to imagine.
It is, and it raises questions about what those planets would be like in that new environment. Would they still be able to support life, or would they become frozen wastelands?
It's hard to say for sure, but it's definitely a fascinating scenario to consider. It makes you wonder what other surprises the universe has in store for us as we continue to explore and learn.
It does, and I think that's a good place to leave our listeners for today. with a sense of wonder, a thirst for knowledge, and the understanding that even in the face of cosmic challenges, there's always more to discover.
Well said. And on that note, we'll bid you farewell, fellow explorers. Until next time, keep looking up, keep asking questions, and keep marveling at the wonders of the universe.